Hello. My name is Albert. I am Application Engineer with IntelLiDrives. Today I will introduce you to IMAC, Visual Programming Application. IMAC Visual Programming Application runs in the web browser. Chrome is recommended. To start IMAC, open Chrome browser, type IMAC:5000 into the address bar and press Enter. IMAC Visual Programming Application will be loaded. IMAC application has four areas: Main Menu, Block Palette, Programming Workspace, and Terminal. Let me start from the main menu. From the main menu, user can open and save IMAC user application files. Establish communication with the iDrives connected to the IMAC controller. Set the communication baud rate between the IMAC and iDrives. Update IMAC software to a new version. IMAC can be updated online or offline from provided installation file. On the left there is Block Palette. There are 8 categories of blocks: Motion, Weight, IOs, Control Flow, Math, Variables, Miscellaneous, and User blocks. Let's start from the motion blocks. The first block in this category is Mode block. IMAC user application is programmed by selecting, dragging and dropping a visual programming block onto the programming workspace. The Mode block contains 2 fields: Motor type. User can select stepper or servo motor. Operation mode. Axis can operate in position mode, velocity or torque modes. Currently only position mode is implemented. Each visual block has 2 attributes: USB channel and axis number. IMAC supports 4 USB channels to control digital drives and IOs. Let's try to program XY table, as an example. In our example I have 2 axes, 0 and 1. Axis 0 controls X-axis. Axis 1 controls Y-axis. Both axes are connected to USB channel 0. For X-axis I select axis number, 0, motor, stepper, mode, position. I am adding another mode block to the sequence and program it for Y-axis. I select stepper, position, and axis number 1. In this example we control 2 stepper motor actuators in position mode. Next block is Profile block. Here we can specify the motion trajectory, trapezoidal or S-curve, velocity, acceleration, deceleration. And in case of S-curve profile, we have to specify the jerk. The jerk is the rate of change of acceleration. We enter trajectory parameters in units of position resolution. For stepper motor they are microsteps, for servo motor, encoder counts. I am going to select trapezoidal profile for X-axis. Enter velocity 200,000 microsteps per second. Acceleration 100,000 microsteps per second squared. Deceleration 100,000 microsteps per second squared. Select axis number 0. I am adding the second block for Y-axis. And do the same what I did for X-axis. The next block is Move block. This block executes the motion. Here we select the move type absolute, relative, or velocity. If we select move type as relative, we enter the distance we want to move. Value should be unsigned. We select the direction of the move, positive or negative. If we select move type as absolute, distance field changes to position, which should be entered as assigned value. Positive or negative direction field is disabled in absolute move. If we select move type as velocity, the distance or position field is disabled. We only have to select in which direction we want axis moves. We are going to program the move type as relative for X-axis. I enter 500,000 counts into the distance field and select positive direction. We add the second move block to the sequence and program it in the similar fashion for Y-axis. We can execute this program and see how axes are moving. I start the program by clicking Run button. 2 axes are moving in sequence, each 500,000 microsteps. Move blocks have wait until done checkbox. If the box is checked, next block in the sequence will not be executed until current move is completed. If wait until done is unchecked, next block will be executed right away. Let me show you how axes move when this box is unchecked. I am going to return the axes to the previous position. I select the opposite direction. I want to increase the velocity and acceleration of the axes. I click Run button. We executed coordinated linear move, rather than two move in sequence. The next block in this category is homing block. I am dropping it onto the programming workspace. The homing is a motion to the position declared as home position. We can declare current position as home position. We do this to set position counter of axis to 0 and establish the new coordinate system. We can also move to limit switches, positive or negative, to establish home position. The position counter will be set to 0 when the axis reaches the selected limit. Wait until referenced works similarly to wait until done in the move block. I am going to move axis to positive direction. I check wait until done for x-axis. I want to set home position as negative limit for x-axis, and do the same for y-axis, by copying the block, and select axis number 1. I click the Run button. After the move blocks have been completed, axes will be moving to negative limits, and reset their position counters.